Welcome students. Today we will discuss about chain rule and the differentiation of implicit functions. So let's start. At first we will discuss about chain rule for function of two variables. Okay. So we have four rules of chain rule for the function of two variables. Rule number 1, let fu be a differentiable function of u and u is a function of x. Then f becomes a function of x and the derivative of f with respect to x is equal to df du into du dx. Okay. Now our rule number 2. Let fu be a function of u and u is a function of xy. That is f, apparently f is function of one variable and u is a function of two variables. So ultimately f becomes a function of xy. X will be a function of two variables, x and y. Then the two partial derivatives of f with respect to x and y, del f del x is equal to df du into del u del x and del f del y is equal to df du into del u del y. Now rule number 3. Let f be function of u and v. Okay, and u and v are function of xy. Then f becomes a function of x and y. Then the two partial derivatives are del f del x is equal to del f del u because f is function of u and v. Okay, and into del u del x we have written del because f and u both are multivariate function. That is why we have written del instead of d. Okay, so del f del x equal to del f del u into del u del x plus del f del v into del v del x and del f del y is equal to del f del u into del u del y plus del f del v into del v del y. Okay, and rule number 4 is let f be a function of u and v, and u and v are only the function of x. Then f becomes a function of x and df dx is equal to del f del u into du dx plus del f del v into dv dx. Okay, so these are the complete list of chain rules for a function of two variables function. Okay.
Now you are instructed to write down 4 rules of chain rule, and now I am explaining what is the difference between df dx and del f del x. See, when f is only the function of single variable x, then the derivative of f with respect to x is denoted by df dx, and when f is multivariate function of x, y, z, t, etc., etc., then the partial derivative of f with respect to x is denoted by del f del x. Two things are totally different. Okay?
Now our first problem is, if y is equal to log of u square plus 1 and u equal to sin x, find dy dx. Okay. Here you can see y is function of u, only the function of u, and u is only function of x. So ultimately y is function of x, and that is why this dy dx is valid. Okay. So we have to use the rule number 1 of chain rule. Okay. Okay. Answer. Dy dx is equal to dy du into du dx. Now what is dy du? You have to remember the differentiation formulas for this type of expressions. Okay. Which you have learned in class 11. So what is dy du? That is 1 by u square plus 1 into 2u. Okay. Into, and what is du dx? That is cos x. Okay. So we have 2u square plus 1 into cos x. But we have to turn this whole expression into x, into function of x. That is why we have to write u in terms of x. So what is 2u? U is sin x. So 2u is 2 sin x and cos x. This cos x. And what is u square plus 1? This is 1 plus sin square x. Okay, and what is 2 sin x cos x? That is sin 2x. Okay, so that very easy. Our second problem, is second problem, if b is equal to sine square u. Okay, where u is equal to x to the power 3 y to the power 4. Find del v del y. Okay. See, here v is function of u. Okay. V is function of one variable, which is u, and u is function of two variables, which are x and y. So you have to find del v del y. Okay. So how to approach? What is del v del y? We have to apply rule number 2. I am writing here, applying answer. Okay. Applying rule 2. Okay. On v. Del v del y is equal to del v. No, this is not del v. Okay, this is dv du, because v is function of one variable, and when a function is only and when a function is only one variable, when function only of one variable, then we have to write dv du. Okay, so dv du into del u del y, because u is function of two variable x and y, and del u del y is partial derivative with respect to y, and when we are partially differentiating a function, a multivariate function with respect to one variable, then let us consider we have to differentiate this. We have to obtain this del u del y. Then we have to differentiate. Then we have to if we are partial differentiating a function u of two variables x and y, and when we are trying to get the partial derivative del u del y, then you have to remember one thing. When we differentiate u with respect to y, then we have to keep x as a constant. Okay, so what is dv du? dv du is 2 sine u cos u. Okay, 2 sine u cos u. And what is del u del y? We have to keep x as constant. Okay, so 4 y to the power cube x square. Now we have to change the variable u. So this is sine 2u 4 y cube x this is the answer. Now our problem number 3 is, if z is equal to u square plus v cube where u is equal to sin xy and v is equal to y square. Find del z del x and del z del y. See here z is function of two variables, that is u and v, and u is function of two variables x and y, and v is function of one variable only y. So we have to find del z del x and del z del y. So we have to apply the rule number 3. We have to apply rule number 3. Okay. So what is rule number 3? Rule number 3 is del z del x is equal to del z del u into del u del x. Okay, del u del x and del z del v into del u del u del y. No, this must be x. This must be x. Okay. So see, what is del z del u? Del z del u is, we have to differentiate only u and keep v as a constant. So del z del u is answer. Del z del u is 2u. And what is del u del x? Del u del x is, see, u is function of sin xy. So when we partially differentiate the u with respect to x, then we have to keep y as constant. So here del u del x is cos xy, and then we have to differentiate the xy into y. Okay, plus what is del z del v? See, okay, when we partially differentiate z with respect to v, then we have to keep constant, okay, as a constant u as a constant. So del z del v, what is it? So 3v square. Okay, and when we partially differentiate with respect to x, then cos xy into cos xy into x. Del u del x cos xy y, okay. And the final one, this is y. This is y. So what is u? U is sin xy. Okay. And this is what is v? V is y square. So v square is y to the power 4. So this is y to the power 4 y into 4x. Okay. Now so del z del u del u del x plus del u del y del z del u del u del y. Okay. So what is del z del u? Del z del u is u, and what is del u del y? Del u del y is cos xy into x. Okay. What is del z del v? Del z del v is del z del v is 3v square. Okay. And what is del v del y? Del v del y is 2y. Okay. Now we have to put u and v as a function of xy. So u is equal to what is v? Okay. Now it is your duty to simplify this thing. So fourth problem is if z is equal to sin uv, okay, where u is function of x and v is also the function of x, then find dz dx. See, at first see that z is multivariate function, okay, variables are u and v, but u and v a function of x, only x. So that is why z is ultimately function of x. Okay, that's why in this problem we are asked to find dz dx. Okay, not del z del x, because z is ultimately a single variable function. Okay, and the variable is x. That's why we are asked to find dz dx. So we have to apply the rule 4. Applying rule 4. Okay, what is rule 4? dz dx is equal to, see, apparently z is function of u and v, so I have to write this del z del u, okay, and du dx plus del z del v into dv dx. Okay. So what is del z del u? See, del z del u is cos uv, and we have differentiate partially uv, so it will be only v. Okay, it will be only v, and we have to differentiate u with respect to x. So what is u? U is 3x square, so 6x. Okay, now we have to partially differentiate z with respect to v, so that is cos uv into, we have to partially differentiate uv, so u. Okay, dot, and what is dv dx? 1 by x. So 6x v cos uv plus u by x cos uv. Now what is vuv? We have to put the value of it here. So 6x, what is v? Log x. Okay, what is cos uv? Cos 3x square log x. Okay, so 6x log x cos of 3x square log x dx cos 3x square x. Okay, so now I will tell you the chain rule of function of 3 or more variables. Okay, suppose u is function of n variables, n distinct variables. U is equal to f of x1, x2, dot dot dot, xn, where x1 is function of p distinct variables, x2 is function of p distinct variables. Okay, and dot dot dot, xn is function of p distinct variables. Then u is ultimately the function of these variables r1, r2, rp. Okay. So the partial derivative of u with respect to rkth variable is equal to del u del x1 into del x1 del rk plus del u del x2 into del x2 del rk plus plus del u del xn into del xn del rk. And if x1, x2, xn are functions of only one variable s, then u will be function of s. Okay. So here du dx is equal to del u del x1 into del x1 sorry, I have written this is d, this is d. So du ds is equal to del u del x1 dx1 ds, okay, plus del u del x2 dx2 ds plus plus del u del xn dxn ds. U is ultimately the function of s, and x1, x2, xn are functions of only one variable s. That is why I have written dx1 ds instead of del x1 del s. Okay. And here homework for you. If v is equal to z sin y by x, where x equal to this, y equal to this, z equal to this, then you have to find this partial derivative. Okay. Very easy problem. Follow the rule and find the derivatives. So now I will tell you how to differentiate a implicit function. Okay. So at first we have to know what is implicit function. Allocation such as f of x, y, z. F is multivariate function of three variables x, y, z. Okay. Defines one variable, say z, in terms of a function of other two variables x and y. In that case, z is called implicit function of x and y, and this can be displayed as z equal to f of x, y. See, if f is function of x, y, z, okay. If we can write z as a function of, as an expression of x and y, then we call z is implicit function of x and y. Now here is an example. See, this is a function of three variables x and z. Okay. See, z can be written as the expression of x and y. So z becomes an implicit function of x and y. Now two theorems are very useful to differentiate a implicit function. Theorem 1. If f of xy is equal to 0 gives y as an implicit function of x, that means we are able to write y as a function of x, okay, in a region on xy plane. Then dy dx is equal to del f del x minus of del f del x by del f del y, where del f del y must be non-zero, And theorem 2 is if f(x,y,z) is equal to 0 gives z as an implicit function of x and y, then the partial derivative of z with respect to x is equal to minus of the partial derivative of f with respect to x by the partial derivative of f with respect to z, and del z del y is equal to minus fy by xz. That means minus of the partial derivative of f with respect to y by the partial derivative of f with respect to z, provided fz must be non-zero. Because if fz is 0, then the expression is not valid. Okay. So our first problem is find dy dx and d2y dx square if x cube plus y cube minus 3xy is equal to 0. Okay. So let f of xy is equal to x cube plus y cube minus 3xy. See, if you will try to express y as a function of x, then you will face some difficulties. Okay, that is why we have to avoid those steps and just do the problem. So you have to write from the given relation y can be expressed as function of x. Okay. So from theorem 1. So from theorem 1, dy dx is equal to, see, minus del f del x by del f del y. Okay. So here f is this, and what is del f del x? You have to treat y as a constant when you are trying to find the partial derivative of x, the partial derivative of x with respect to x. Okay. So 3x square plus 0, because we have assumed that y as a constant, minus 3y. And what is del f del y? Del f del y is, we have to treat x as constant, as a constant. So here we write 0 and 3y square minus 3x. Okay, so this is our dy dx, and if you you have to try this, you have to just do some calculation. Okay, that is why I am ignoring this. This will be homework. This will be homework. Okay, now the answer will be minus 2xy by y square minus x whole cube. We have to do some calculations which are very big. Okay, our problem 6 is, if f of x, y, z is equal to 0, conclude that del x del y at z, okay, into del y del z at x into del z del x at y is equal to minus 1, is equal to minus 1. Okay, here we have to apply theorem 2, theorem 2 to get what? To get del x del y del z del z del x. Okay, so here what is del x del y from the theorem? Del x del y is fy by fx, okay, fy by fx, and if we partially differentiate this with respect to z, then we have to write this. Sorry, we have to write this. And z is constant, okay. Now similarly del y del z, z is equal to fz fy, fy and del z del x and y is equal to fx by fz. Fx by fz, okay. So what we have to do that del x del y with respect to z, but z is constant here. Here z is constant, here y is constant. Okay. Sorry, here x is constant. Here x is constant and here y is constant. So this into, we have to just multiply this. Okay. Del x del y with respect to z, del y del z with respect to x, and del z del x with respect to y is equal equal to see minus fy fx into minus fz fy into minus fx fy equal to minus. Okay, I'm stopping here the class.